Today I am going to talk about Gauss Jordan method. Here I will solve the system of linear equation. So now here Gauss Jordan method theory. So system of linear equation, we can write Ax is equal to B. So here where A is the coefficient matrix, X is the column matrix of unknown variable, and B is the column matrix of constants. So now we have to form the augmented matrix AB, combining A and B matrix, and then we have to do the matrix inversion. So from that matrix inversion we can easily get X, right? Now I'll show you how to solve the system of linear equation by using Gauss Jordan method. Now here is the problem statement. Solve the following system of equation using the Gauss elimination method. So 2x plus 3y minus z is equal to 5, 4x plus 4y minus 3z is equal to 3, and 2x minus 3y plus 2z is equal to 2. Now general equation we can write a11x plus a12y, means a11 is the coefficient of x, a12 is the coefficient of y, a13 coefficient of z is equal to b1, and a21x, a22y, a23z is equal to b2, a31x plus a32y, a plus a33z is equal to b3. Now from this general equation we can form the matrix A. So that is a11, a12, a13, a21, a22, a23, a31, a32, a33. So we put from this equation, so that is 2, 3, 1. So 2 is the coefficient of x, 3 is the coefficient of y, and then z coefficient is minus 1. So 2, 3 minus 1, 4, 4 minus 3, and 2 minus 3, 2. Now next is here is the B matrix, that is column matrix of constant matrix. So whatever constant is there, so 5, 3, 2, so that is nothing but a B matrix. Now we have to take here for the Gauss Jordan method, we have to take identity matrix or unit matrix. So that is I is equal to 1, 0, 1. So in diagonal all this element will be 1 and rest of the element will be 0. So that is nothing but a unit matrix. Now first we have to construct the augmented matrix. So we have to put A, then B matrix, then I matrix. Now we have to do, so here, so this is the diagonal. So we have to take the diagonal element and we have to do that elimination method. So all the other element will be we have to make 0. Okay, and we have to make this matrix as a identity matrix. So automatically identity matrix will transfer to that inverse matrix, and this B will transfer, and that will give the solution of that solution of the system of equation. Now we have to solve this. So first it is like a Gauss elimination method, but we have to do that Gauss elimination two side, so in that lower side and upper side. Now so this is the construct augmented matrix. So 3, 1, 2, 3 minus 1, so that is A matrix, this is B matrix, and this is I matrix. So 2, 3 minus 1, 5, 1, 0, 1, 1, 0, 0, 2, 4 minus 3, 3, 0, 1, 0, 2 minus 3, 2, 2, 0, 0, 1. Now here this element is the pivot element. So pivot element A11, that is 2. It is similar as a Gauss elimination method. So if you don't see that Gauss elimination method video, so please you can see that, so it will be very easy for you. Now that A11 element is 2, and then we have to take the multiplier. So that multiplier will not be changed throughout the operation. So here we are going to make this element 0. Okay, so this element we are going to make 0. So for that we have to take the multiplier A21 by A1, and then we have to do the row operation. So R2 will change, so R2 minus this multiplier into R1. So A21 by A1 is nothing but A21 is 4, A1 is 2 into R1. So now we have to do the operation. So here A21 minus A21 by 1, A1. So we have to do like that. So entire row we are doing that operation. So and we put all this value. Okay, so now after doing or putting all this value, and after doing the that operation, so we'll get this element is 0. Now you can see that, so this element 0. Okay, and then all this the element actually changes value. Now we have to make this element 0. Similarly we have to take that multiplier, so A31 by A11 into R3. So we have to do the operation. Ultimately we will get, so this element is 0. Similarly, we have to make this element 0. So again, so this will be the pivot element, and again we have to take the multiplier a32 by a22. So here minus 6 by 2. Okay, and then again we have to do the operation to make this element 0. So everything is given, so you can take you can do by your hand, do by pen and paper, your own hand calculation, so you can easily understand that things. Now we will make this 0. So now here we have to make this element 0, this element 0, and this element 0, and then we have to divide with diagonal element, and it will become a identity matrix. So first we have to make this element 0, so 2 3 position 0. So again, so that will be the pivot element. Again we have to take the multiplier. Now this will be the pivot element, so we have to take that multiplier and do the Gauss elimination method. So ultimately we will get here, so this element 0. So next we have to this element 0 and this element 0. So again we have to take, this is for this, we have to take the pivot element, and again we have to do that Gauss elimination method. So doing that Gauss elimination method, we will get this element, that element is 0. Next we have to do that this element 0, so this will be your pivot element. Okay, now again we have to do the row operation. So by doing the row operation, so we will get this element 0. Now here 2 minus 2 6, all these elements, diagonal element are there. So now we have to make this matrix or identity matrix. So first row, if we divide it with 2, so this will become 1. So for second row, if we divide with minus 2, that will become 1, and third row, if I divide with 6, so that this element will be 1. So this first row operation, second row operation, third row operation, after doing that, so we will get that identity matrix. So this become identity matrix, this will be X, and this will be the A inverse. Okay, so now, so we'll get that. So this is identity matrix, this is X, and this is A inverse. Okay, so now this is I, X, and A inverse. So now from that, so not a matrix, this is X. So this is the solution. So X is nothing but x1, x2, x3, or x, y, z. So that will be 1 2 3. Okay, so that is the final answer, and you will also get the inverse of a matrix. So if any matrix is given, so if you want to find out the inverse of a matrix by using Gauss-Jordan method, so we can follow the same procedure, and we can easily get the inverse of a matrix. So that's it. Thank you.